Hi, I'm Pedro Sodré, the manager of the Mage Hand group. I'm now here to show you the Deliverable 2 of our group. So let's start with the schedule. We made this new Deliverable 2 because, as we said in the email, we need to delay the Deliverable 2 because of some problems that we have. And then because of that, we advanced the tasks from the another deliverables, from Deliverable 3, Deliverable 4, and Deliverable 5. So I have like a resume right here. So what we need to do in the deliverable 2 is 58 hours. But because of the problems, we only could get the like 13 hours of this 58. So because of that, we need to advance for 5.5 to complete to be 00. So that's the hours that we delayed in the deliverable 2. From these 13 hours, we done 10.4, and of these advanced tasks, we've done for 1.6. So we have a total delay of 6.5. We delay that because we have some problems with the deliver of some components, specifically the camera and the display. That's because we worked a little more, so we make the task faster than we thought, and that's why we have like much less time worked, and we still have delay. Uh, so yeah, we know we should advance other tasks, but a lot of tasks is dependent of others, so we don't get some tasks that we can advance. So because like a lot of tasks in the deliverable tree needed the deliverable tree to be done. So you can take a look more of here. So the tasks that we are delayed is like test the camera and test the display because we don't have the components. So it's still not started in this two. And also we have some printing 3D models, but we think we could have this since Thursday. And this is the generate pix QR code. Is readable in the display. Test it. So since we don't have the display, we can test it. But this is all set up. That's why it is in progress. If the components arrive tomorrow in Wednesday, we think like in Thursday, it will all be done and will be 00. Will be on schedule. So that's it for the schedule. Let's go to the deliverable. Uh, Deliverable 2. So since we couldn't do the mechanical part of our project, we advanced the software design. This is the state chart, the state machine. So we divided into in some states our machine. If we can see the original, I've tried to go a little faster on this part. Uh, so we have the booting phase where the SP barrel will set up all the things. I will take a look more of this later. We have the introduction phase where is the rest state of the machine, let's say like that, because it will be like in this stage most part of the time, like waiting for a customer. If no pix is configured, it will be all in the introduction phase because it can get a payment, so it can work. So it will be introduction phase like a lot of times. If a hand is detected, it goes to the confirmation phase. We say detect stop gesture because it's the open hands that, so the system detects the open hands, that is the stop gesture, and then goes to the confirmation phase. If no hand detected, it will go back again to the introduction. Here, if the text thumbs up, it goes to the selection phase. That is the phase the state where the customer will select the candies, the pouring phase where the customer will push and select which amount of candies he wants. Then goes to the decision phase where the customer will accept or reject the candies. Then go to the payment phase where the customer will pay, for course. And after this, it will go back again to the introduction phase. We have something like if make a payment is approved, if 3 months pass without payment, it will also go to the introduction phase. But here the candies will be in the rejection side, in the rejection side of the machine, and here the candies will go to the customer. In the decision phase, we can also detect a thumbs up to the selection phase. It's like is a resume of states where we showed it in the initiation phase. So sorry about that. I scrolled down a little bit. So let's take a look at in the booting phase. So it basically tries to connect to the Firebase, verify if the connection was successful, load the information from the Firebase, from the database, create something that will listen, and this is if the candies will be in the structure. So for example, the system was turned off, and then it's turned on, and even if in the turn off, the candies are in the cups. So that's why we take this. So if the system was in payment, so it's like a variable that we save. So if something happens with the light, for example, if the light goes down for some reason and the machine stop working, this will save like a payment phase, and then we'll go back and activate the servo motors to make the cups to deliver the candies to the customer, even if if happens like something like a blackout and the lights uh, go up again. And then if no, it will just reject the candies. In the introduction phase, the system will reject the amount of candies. Basically, in this phase, it will see if the payment key is configured, show the message on display saying it needs to be configured. It will consume the Firebase data, and after detecting a stop gesture, so someone wants to buy something, it goes to the confirmation phase. So display shows the message saying a customer was detected, instruction to proceed. It reads the camera to detect a thumbs up gesture. So yes, I want to buy something. So you go thumbs up, and then goes to the selection phase. If it loses track, like I said, it goes to the introduction phase. I will go to the original to see more of the selection phase. So shows the message to select the candy. Reads the camera, so it's looking for the customer to select the candy, so it needs to have his hand on one of the sides of the machine. So in the left, he will select the left candy, in the right candy. Thumbs up to confirm that you want this candy, thumbs down to cancel, and then goes to the introduction phase again. And activate the servo motors to discard the candies, of course. If he accepts, it goes to the pouring save. So I want this candy, and then goes to the pouring phase. And if he loses track for of a hand, more than 30 seconds, it will like discard the candies too, and also save into the database. And here it will like select the candy. So let's go to the next one. That is the pouring phase. So we are going from this to this. So let's build original. Let me skip all these diagrams. So in the pouring phase, it goes to the displays true. It will detect basically these three gestures: fist, stop, thumbs down. Thumbs down to reject the order. Fist to push the candies, and stop to stop the candies. So you don't need more. And then if thumbs down, it stops the DC motor from moving, shows a message to confirm, and then discard the candies like the other ones. Here, if loses track of a hand, so it's like the same from the above. If stop is detected, it will stop the DC from moving and shows a message there that is stop detected, and then goes to the decision phase. That is the next phase. If a phase is detected, it will calculate how much. If the cup will overflow. It will check if have candy to fill up the cup. So if not, it will show a message there's no more candy. If not, if there's candy, so it will continue like pouring candy into the cup, and it will move the DC motor to move the Archimedes screw. So, and right here we will calculate how much candy is currently in the cup and saves this information on volatile memory based on how much the DC motor moved. This is the decision phase, where the customer will accept or reject the order. You can see more right here. So it shows a message. You can accept, reject, or continue if you want to buy another candy. So thumbs up if you confirm, accept the order. Thumbs down, reject the order. Peace gesture to continue buying and buy the other candy, or continue buying the same. If it loses track, if do the same thing, it will discard the candies. It will update on the purchase history that the candies was rejected because it loses track of the hand. And depending, this is for confirming, so it will wait 4 seconds to confirm if the customer wants this, the gesture that he's making. If thumbs down, reject like this. If thumbs up, it goes to the payment phase, so he wants to buy to buy, and the piece to continue buying to put the other candy. And the payment phase, we can go right here. So saves the payment mode. So if occurs blackout or the lights go down, we can save this, and when it comes back, it continues. It will start a 3-minute payment timer, and will shows the QR code, the pics, in the display. Let me check. It waits for a response from the Pix API. It reads the camera, which detects a thumb down. So if thumbs down, it is detected into these 3 minutes. So it will discard all the candies. Of course, they have something to confirm too. This will, if it's a good response from Pix API, it will continue. So the payment was accepted. The servo motors will deliver the candy to the customer. If it's a bad response, the payment was denied, and the customer should try again and like start the 3 minutes payment timer again. If the timer expires, it will reject, cancel the order. And after this, goes to the introduction phase again. This is the Firebase thread. Sorry. So this is the Firebase thread, where you basically listen to notifications and updates the queue. This is the gesture recognizer. That is another software. So it will explain if non-gestures, we consider all gesture that are not of its interest at the moment as non-gestures. Uh, Non-gestures will be in fact considered as one type of gesture and can have callback functions assigned. Non-gestures also serve to the purpose of the serve to the purpose of consider person drop the gest that is being confirmed. So this is the same. So start a function call it resets all gesture counters, confirmation flag. So start capturing video. So you can understand more. Take a look. I mean, I'm out of time, so I want to be quicker. So right here we have like the methods of each servers from the motors, from gesture recognizer, from LC display, from the Mage hand. We have a dictionary. So in the payment we have the payment key, the candy, that the candy one that have name, price, volume, image, the candy too. We have the ERG diagram. So we have the sales. In the sales we have the order. What is the difference between sales and the order? Because we divided this into two. So for example, if the customer order 2 candies, it will have 2 lines. The order is the same. The sales will be different because it's the primary key. And we have the each one of the rows have each one of the item informations. We have the storage too to see how much quantity it is in the machine, and the user ID to make the login. We have also the use cases where in the app the owner can set up Pix key, create or remove new user, change username and password for login, insert update candy information, receive shutdown notification, see sales history. The employee can only do these 2 things. This is optional, so but we also do that right here. And the use case in the machine, so the customer can select candy. It extends so he can select the second candy, place the amount of candy, accept treasury order. That's all we see in the state machine. And the owner can fill the machine with candy, collect or reject candies, and turn on or turn off the candies. So this is one of the tests of the hardware. So this is the servo motor working. So the first test in the components is done. So servo motor is working properly. This is the testing into the Archimedes screw with the DC motor. Let's go over here where it moves. So the Archimedes screw with the DC motor. We have other videos too. We also have the mechanical redesign that we do with the feedback that you gave us last week. So right now we have this box, so the candies will not fall down into the floor. We also have these things that will be made of MDF, and this will be made by 3D printing. This where the servos will be locked. And we also have the interaction between PWM and the Firebase. So in this video we can see the notification working. So here's the app, and here we will receive the notification from the Firebase. And basically is that. Thank you.